Welcome to the DIY Honda Garage channel. This presentation provides a detailed troubleshooting guide for DTC P0222, which indicates a low voltage condition in the throttle position TP sensor B circuit for the Honda CR-V 2023 and onwards. The TP sensor is fundamental for informing the powertrain control module, PCM, about the position of the throttle body, which in turn regulates the amount of air entering the engine. A failure in this circuit can lead to a decrease in vehicle performance or even failure to operate correctly. In vehicles, the location of the TP sensor is integrated with the throttle body, typically mounted on the intake manifold. The PCM processes the data from the TP sensor to manage various engine functions, making its proper operation essential for optimal performance. Engaging in thorough diagnostics ensures that any underlying issues are resolved, promoting vehicle reliability and safety. DTC P0222 signals an abnormality detected in the throttle position TP sensor B circuit due to low output voltage, causing the PCM to store the error code. The TP sensor is crucial as it relays positional data to the PCM to facilitate responsiveness in throttle control. Its location within the throttle body means any issues may hinder air intake performance, leading to engine inefficiencies. The TP sensor is combined with the throttle body assembly, representing a singular unit that is both electronically and mechanically integrated, operating in tandem with other components managed by the PCM. A failure to record the proper voltage output at the TP sensor indicates that further diagnostic steps need to be taken to pinpoint the root of the problem, assuring that all interconnected systems, such as fuel injection, are functioning as expected. Inspection is primarily focused on both the sensor itself and the associated circuits. Several potential causes can lead to the triggering of DTC P0222. A faulty throttle position sensor itself could fail, supplying incorrect voltage output to the PCM, which is the first suspect in diagnosing this low voltage warning. Circuit wiring issues, such as damaged, corroded, or disconnected wires, can disrupt the electrical signals necessary for proper throttle functioning, leading to erratic or improper sensor readings. Furthermore, if inspections reveal that both the sensor and wiring are functioning well, a malfunction within the PCM might be the underlying culprit. The PCM is responsible for processing inputs from multiple sensors. Thus, its failure can cascade into several other issues, highlighting the need for comprehensive diagnostics. Each of these potential causes dictates specific testing methods as outlined in this guide. The manifestation of DTC P0222 can result in a range of symptoms affecting vehicle performance noticeably. Drivers may experience poor throttle response, where the vehicle fails to accelerate properly when the accelerator pedal is engaged, due to incorrect information being relayed about the throttle position. This sluggishness can lead not only to a frustrating driving experience, but also increase fuel consumption, as the engine may compensate by drawing in more fuel without the proper air intake. Other performance issues can arise, including erratic engine behavior, where the engine may hesitate, misfire, or even stall intermittently due to varying input signals to the PCM. Observing these symptoms while driving is critical for diagnosing the fault correctly, as they signify a failure in the smooth communication between the throttle body and the PCM, essential for maintaining proper vehicle operation. The first step in troubleshooting DTC P0222 begins with turning the vehicle to on mode while ensuring the engine is not running. This allows for proper diagnostics without the influence of engine operation. Utilize the Honda Diagnostic System, HDS, to check the TP sensor B voltage. If the measured value is less than 0.3 volts, this will indicate a failure in the circuit or the sensor, confirming that the issue mimics the reported DTC condition. Documenting any voltage readings is critical as it provides essential data points for further analysis. This preliminary check can quickly validate whether the TP sensor is functioning within expected parameters or if additional testing of the circuit is required. Therefore, it is an essential first step in the troubleshooting sequence. Following the initial voltage test, the next troubleshooting step is to inspect the throttle position TP sensor integrated within the throttle body. The primary focus should be on the sensor itself, checking for proper connections, signs of wear, or any visible damage. Ensuring that the wiring leading to the sensor is intact and securely connected is vital, as even a loose connection can yield erratic sensor readings. If any irregularities are found during this inspection, addressing these concerns may resolve the DTC condition. It is essential to recognize that the integrity of both the sensor and its connections plays a crucial role in maintaining accurate communication with the PCM. Evaluating the condition of the throttle body assembly can often reveal potential points of failure that warrant further monitoring or replacement. The third step in this diagnostic process requires inspecting the VCC3 and THL2 circuits, which are integral for the functionality of the TP sensor. Begin by checking the continuity and resistance of these circuits to identify any possible breaks, shorts, or high resistance points. During this inspection, ensure that the power supply VCC3 circuit has less than 1 ohm resistance, as this would indicate a good electrical path. Similarly, the THL2 signal should show greater than 1 megaohm resistance when tested to ground. This step will help ascertain whether the circuit integrity is compromised, leading to the low voltage condition logged in DTC P0222. If any abnormalities are detected in circuit integrity, appropriate repairs or replacements should be executed immediately to restore functionality. In the final step of troubleshooting DTC P0222, you will focus on checking the functionality of the Powertrain Control Module PCM. If all prior inspection items are confirmed to be in normal conditions, you may conclude that the PCM could be at fault. This can involve using specialized diagnostic tools to evaluate the PCM's operation in processing sensor inputs. A malfunctioning PCM may not correctly interpret the data from the TP sensor B, leading to persistent DTC indications. It's essential to cross-reference findings from previous tests to ensure a systematic approach has been followed, confirming that all components and circuits have been thoroughly checked first. Finally, if the PCM is determined to be the issue, replacement of the module may be necessary to resolve the DTC P0222 condition effectively. To confirm the quality of repairs conducted for DTC P0222, the final verification step involves clearing the diagnostic trouble code from the PCM using compatible diagnostic equipment. After the DTC is cleared, a test drive is necessary to replicate typical driving conditions, which allows for re-evaluation of the vehicle's systems. During this time, closely monitor the vehicle's performance, particularly in areas that were previously identified as problematic. Successful troubleshooting will result in no reappearance of the DTC after the inspection and normal performance metrics from the throttle body input readings. Documenting results after the test drive is essential for both historical records and confirming that repairs have effectively resolved the underlying issues. This final verification step assures both the technician and vehicle owner of the reliability and operational capability of the vehicle. To minimize the occurrence of issues related to DTC P0222 in the future, it's crucial to establish a preventive maintenance routine focused on components related to the throttle position sensor. Regular inspections of the throttle body and TP sensors can help catch any wear or damage before it escalates into significant failures. Additionally, maintaining the integrity of wiring that connects the TP sensor to the PCM is equally important, as fraying, corrosion, or loose connections can lead to erratic sensor data transmission. Scheduling these checks based on vehicle usage and mileage can ensure that the vehicle operates smoothly without unexpected interruptions. Developing a consistent regimen of maintenance not only boosts vehicle longevity, but also drivers' confidence in their vehicle's performance over time. In summary, addressing DTC P0222 requires a careful and systematic approach to diagnostics, ensuring that each component tied to the throttle position sensor is functioning within expected parameters. This guide outlines the essential steps to isolate potential issues, ranging from the sensor to the PCM. The importance of thoroughly verifying both the electrical and mechanical components cannot be overstated, as even slight deviations can trigger significant performance issues. Utilizing advanced diagnostic tools can ease the troubleshooting process and lead to a more efficient resolution. Additionally, adopting preventative maintenance practices can help maintain vehicle reliability and performance long-term. With proper attention to detail and careful repairs, the root causes of DTC P0222 can be identified and resolved, ensuring smooth operation and vehicle confidence. Please like and subscribe to the channel. See you next time.